Okay, so what we want to do now is that we want to use generics for our pallets. So we already know a little bit about generics because when you use the B-tree map, for example, we can see that there are two types that I pass to the B-tree map. And the same way I pass the types here when I define my pallet, I want someone that is using the pallet, in our case, our runtime, also to define the, let me just remove this, yes. Also to define the types instead of having it hard-coded inside. Imagine that if we had the B-tree map and the types are hard-coded inside the B-tree map. So we would have only one way of using the B-tree map. And we want to have this flexibility in our pallet to someone who is using the pallet to choose the types this person wants to use. So that's why, and the way we do this is that we define in our pallet, instead of having this definition, we define the struct that depends on two types, AccountID and Balance. And when we implement this, we also pass these two types as the types that needs to exist. And of course, when we do this, everything breaks. And why it breaks? Because now the types are not concrete anymore. They are abstract. So I must tell the compiler what these types, what kind of interface this type implements, because it can't be any generic type. It needs to implement some specific features. For example, the account ID must have the clone interface, because if it doesn't have the clone interface, you can't clone it. So the way we do this in Rust is we add this where clause here, and we say, okay, the account ID is an order, must have an order, and also must have a way to clone, for example. And let me just add these types, these traits that we included in the last lesson when we imported the num Craig. And then the balance must have this implementation of zero, a way to have a zero element, and must implement the checked sub, the checked add, and the copy. Now we have to change here because we can't use this zero like this. We must use the balance zero implementation. So now depend on the type what zero is. So instead of hard coding a zero here, we depend on the implementation of the zero interface of the past type. And the amount also needs to be not a value anymore, but a pointer to the value, and everything is working here. But yet we are not finished, because now we must define the type here. Remember, the idea of adding types, generics here, is that we want to define the types outside. So we will remove these types from here, and we will add these types over the types, and then let's add the types here inside. So we can define the types when we create the pallet in the account ID and types balance. Needs to be public. And it needs to be public. Yeah. So right now, if I didn't forget anything, if I run my code, it will work. So now I defined the types here outside, and I can change the type, and automatically the pallet will be, the balances pallet will be using these defined types instead of having it implemented inside it. So here, everything I have here is completely generic. So this is what we have right now.